part B of this problem, if we choose the strategy of expanding out the brackets, we're going to end up with a fairly messy looking expression. So what we really want to do is we really want to use this substitution. So we're going to use another let statement, and we're going to let the a value in this case be the inside function. So we have a squared factor and a linear factor and a constant term. So if we do replacement and let x squared minus 4x plus 4 be the a term, we can rewrite this expression in terms of a. So we're going to end up with 6a squared plus a, 1a, minus 1. And then we can factor this based on this expression. So it's a quadratic with a leading coefficient. So 6a squared, negative 1. So I'm looking for two numbers that multiply to negative 6 and add to positive 1. So that's going to be positive 3a and negative 2a. So my common factor here is going to be 3a. The common factor here is going to be negative 1. Vertically here, the common factor here is going to be 2a, and then this is going to be positive 1. So there's my factored form. So I'm going to rewrite this with 2a plus 1 so 2a plus 1, and this becomes 3a minus 1 . Okay, so this is our factored form in terms of a. Again, we don't want the a, we want it in terms of x's. So I'm going to do my replacement back. In this case, because I factored in terms of a square, I don't end up with a fourth degree polynomial as if I had multiplied this all out. So if I multiplied this out, I'd end up with x4s, which would be quite difficult to factor. So by doing this, it allows me to factor as a quadratic. And then these terms now, instead of having a linear term times a linear term, I'm now going to end up with a quadratic times a quadratic. So this, instead of being a, is going to be x squared minus 4x plus 4 plus 1. And this is going to be 3 times, instead of a, I'm going to replace that with x squared minus 4x plus 4. Make sure I put that in brackets. Minus 1. Okay, and then I need to look at these brackets and see if they are themselves factorable. So 2x squared minus 8x plus 4 plus 1 gives me plus 9. In the right-hand bracket, I'm going to end up with 3x squared minus 12x. This is plus 4, so I'm going to end up with plus 12 minus 1, so minus 11. Sorry, plus 11. Not minus 11, so that's going to be plus 12 minus 1. So these now I have to check for if they are factorable. So I'm looking for two numbers that multiply to 18 and add to negative 8. Well, those two numbers don't exist. The factors of 18 are 3 and 6. That doesn't work. 2 and 9 don't work. So this is not factorable, so I have to leave this as is. So this is prime. Then I need to check the other factor for other quadratic to see if I can further factor that. So I'm going to end up with 33. So two numbers that multiply to 33 and add to negative 12. Well, the factors of 33 are 3 and 11, 1 and 33, and there's no other factors, so none of them will add to 12. So this is not factorable as well. So this is prime, so we can leave it as this quadratic, those two quadratics being multiplied to each other. And that then represents the fully factored form.